Let's take a look at some of these specialized data storage engines and the ecosystem that goes along with them. The first one in our list is ElasticSearch. ElasticSearch is a general purpose search and analytics engine. Now, before Elasticsearch, what used to happen was that there is a library called as Leucine. It's written in Java and it's one of the very popular library for information retrieval needs. Now, on top of this library was built a software called as Solr, S-O-L-R. Now, this Solr was used at many places for search needs and recommendation, and it also has some added capabilities of query recommendations and so on. The downsides of Solr was that Solr in itself wasn't very good at scaling, and if you had to run multiple clusters or do multiple things, there were a lot of nuances and issues that one would have to deal with. So the other evolution that happened on top of Solr was Elasticsearch that came. Elasticsearch is built on top of the same library, Leucine, and Elasticsearch has been designed by ground up to be highly scalable to satisfy the needs of a web scale in terms of data storage, search, and information retrieval use cases. That's how it evolved. Very quickly, it became very popular. Almost everyone started using Elasticsearch for any search related needs. However, as the ecosystem continued growing, a lot of people started using Elasticsearch also for infrastructure monitoring and telemetry use cases apart from search and recommendations, because there weren't very good tools or systems in place which would do infra monitoring or telemetry kind of use cases. So Elasticsearch was a very popular choice. As the ecosystem kept on growing, the ELK stack or the ELK stack was formulated, which is more of an Elasticsearch ecosystem. So the E stands for Elasticsearch, the L stands for Logstash. Logstash is an ingest transform software that is essentially used to ingest large amount of data from any data source into Elasticsearch. It also has the capabilities to transform these data before it sends to Elastic for storing them. And then there is another software called as Kibana, which is used to visualize the search and to interact with it and do other kind of visual referencing and visual query based on Elasticsearch. Elasticsearch grew to be very popular in the use cases that it is catering to. There are a lot of ways in which one can write plugins for Elasticsearch, and that will help you, for example, integrate learn to rank kind of algorithms into your search system. And somewhere during the similar time when Elasticsearch was being developed, another software that was being written was InfluxDB. Now, InfluxDB has a very specific. InfluxDB is a time series database, so it's very specific for any time series information that we want to store, and it quickly became the popular choice for infrastructure monitoring and telemetry related purposes. And just like the ELK stack in Elasticsearch, there is a tick stack in InfluxDB. Tick is for telegraph, influx, chronograph, and capacitor. Now, telegraph is the software system that is responsible for collecting data. It acts as an agent and it runs in the background at server or other places wherein you want to collect the data. It's a plugin based system, so one can write any plugin to capture data from any stack or any system. InfluxDB is a data store, and chronograph is a tool similar to Kibana that is used to visualize data. And Tick has one additional component called capacitor that takes care of processes and alerts. Now these are very important stacks of the ecosystem because this is what happens in a typical production scenario. Like once you are monitoring an infrastructure or a telemetry data, you don't simply want to store them and visualize them. You also want to put some sort of processing, rule-based alerts or other kind of alerts into the system, and that's where the tech stack in its completeness is able to cater to all these different needs. So depending on the application use case, one of the most popular choices to go with is either Elasticsearch or InfluxDB. If you are specifically looking at time series database, InfluxDB is the default choice to go with. And if you are looking for a more generic search and analytics use case, then Elasticsearch might be a better suited tool for you. Now moving on to data warehouse. Now data warehouse are a database system wherein all the data in an enterprise is centrally consolidated into a data management system. And that's what data warehouse is. It was created to cater to the business needs of intelligence, BI, and analytics. And the most intended use case was to perform query and analysis on business data that is coming in from various sources. For example, your transactional data, your logs, enterprise data, and so on. It contains a large amount of historical data that is present in the warehouse. Now, in a data warehouse, the fundamental thing about data warehouse is that data needs to be structured, which means that it is stored in a relational database, and before storing this data into the data warehouse, you have to perform some sort of a transformation to the data so that it is in accordance to the schema or structure that is used to create that particular data warehouse. And that's where some of the typical elements of a warehouse are a relational database that stores the data. The other one is ETL or ELT, which stands for extraction, transformation, and loading. And because without this, you can't really structure the data and put it in the warehouse. And the other element is analysis, reporting, or data mining element, which is how the clients typically interact with the warehouse. The downside of warehouse is that they are proprietary and expensive, and they can't really handle modern data requirements, which focuses more on advanced analytics and machine learning use cases. So as an evolution of data warehouse, the industry came up with data lake. Now data lake in some sense are similar to data warehouse, wherein it's also a central consolidated and cataloged data management system, and it holds a large amount of data in its raw form. Now, this is a key difference. In warehouse, we saw that data has to be structured and transformed because that's how it's stored. Lake, on the other side, stores data in its natural raw form. It can also store data in its processed form, in which case the raw data and the processed data, or any intermediate data, if we want to store them, can be stored in data lake. And it typically uses a flat architecture and object store to store data, because that's how the flexibility in terms of storing data in its raw form comes into picture. There are additional metadata and unique identifier associated with every object that is stored in the lake, and many applications can take advantage of it. Some of the key challenges of a lake are reliability, performance, and security. When we talk about reliability, it means that sometimes it can be difficult combining batch and streaming data in a lake, and there can be data corruption and other factors that reduce the reliability of a lake. With respect to performance, typically when the size of a lake grows, that slows down the performance. And there are other bottlenecks, for example, metadata management and improper partitioning that could degrade the performance. With respect to security, I think the biggest issue with Lake is that there is a lack of visibility and ability to update and delete data. And because of this, the requirements of regulatory bodies are not met at times. and that becomes a security issue. So, as another evolution of data lake, recently there is a Lakehouse architecture that is coming up. Now, Lakehouse architecture is a data management system that combines the best of data lakes and data warehouses. So it is a low cost and directly accessible storage that also provides traditional analytical DBMS management and performance features. For example, data versioning, auditing, indexing, caching, and query optimization. They are especially a very good fit for cloud native environments wherein the compute is separate from the storage. So that's where Lakehouse has been coming up as a very promising solution for modern data needs, which includes advanced analytics and machine learning. So the system or a tool that a software that implements a Lakehouse architecture is Delta Lake, and is gaining very popularity amongst data engineers to store data and to perform advanced analytics on top of it. Now here's a quick comparison between data lake, data warehouse, and data lakehouse. And as you can see, Lakehouse combines the best benefits of a lake and a warehouse as well. Now let's talk a little bit about ORMs. ORM is object relational mapping, and what happens is that in most cases when you are writing an application, you don't write the SQL queries or any other ways to interact with database in its most native form. So that's where ORM comes into picture, because it brings an object-oriented approach to databases. So this is a layer of abstraction on top of the database or other systems that helps you to query and manipulate data in object-oriented manner. And there are various libraries that implement ORM techniques, which is why whenever we talk about ORM, there is a library that is associated with it. And the prime reason why one would want to use ORM is number one, that it saves time, because it has a lot better APIs that helps you do things very quickly. It's flexible, because once you, let's say, write your application using an ORM, it can completely abstract out the underlying database. So for example, you can switch from, let's say, MySQL to Postgres without rewriting your entire application altogether. Some of the most popular examples of ORM are Hibernate in Java, and when we talk about Python, it's Django ORM or SQL Alchemy. And similarly in C# there is nhibernate. So that's how we typically write applications and interact with databases.